Hi Monarchs, in this episode our goal is to graph exponential functions. We are going to be graphing by using tables of values such as this. So we have an exponential equation, y equals 2 to the x, and we're solving this equation, or I'm sorry, we are filling in the table. Okay, so I'm going to actually start at 0 and to fill in this table. So 2 to the 0, anything to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. And 2 to the 3, 2 times 2 times 2 is 8. So we filled in this. Now for the negative exponents, we could remember that they are the reciprocal of the positive exponents. So the negative exponents, if we were to plug in -1, we would have 2 to the -1, where this part would move down and it would become 1 over 2 to the 1, which is 1/2. So that reminds us that 2 and 1/2 are symmetric, that they're reciprocals. So the next one up will be, instead of 4, it'll be 1/4. And instead of 8, it'll be 1/8. And we have our table of values for y equals 2 to the x. The key is that all of these pairs are reciprocals. Okay, so if we plot these points on this graph, I'm just going to start here at 0, 1 again. So we're at 0, 1. Then we're at 1, 2, 2, 4, and 3, 8. Now for these fractions, so we're going over 1, so left 1, up 1/2, so it's basically there. Then left 2, up 1/4, left 3, just up 1/8, so just barely approximating that. And by connecting these graphs, by connecting these points, we could see that the shape of our graph is going to curve, and it will approach the x-axis, but since we're always going to 1/16 and so forth, we're actually never going to hit that x-axis. So the x-axis itself is called an asymptote, meaning that we're never going to actually get there. So graphing another one, now if we plug in 0 for x, we'll have -1/2 times 2 to the 0. So in PEMDAS, we have to actually do the exponent before we multiply. So this is not -1 to the 0. Instead, we have to do the exponent first, so 2 to the 0 is 1, then that's times -1/2, which is -1/2. If we plug in 1, we would have -1/2 times 2 to the 1, so doing the exponent first, times -1/2 is -1. Plugging in 2, we would have -1/2 times 2 to the 2. So 2 to the 2 is 4, times -1/2 is -2. So in the pattern, these numbers are doubling, -1/2, -1, -2. So going in the other direction, it would be -1/4, -1/8. So plotting these points, I'm just going to start with 0. We're at 0, -1/2, so that's about right there between 0 and -1. Then we're at 1, -1. We're at 2, -2. And then we are at -1, -1/4. So we can see that we're getting closer and closer to the x-axis, but we'll never quite get there. And our graph curves like this. So we have an upside down of the prior graph because of that negative there. Discovering that all of our graphs are going to be of this shape right here, with a curve that approaches the x-axis but never hits it, then we only need a little bit of evidence to make that graph. So to graph this one, y equals 3 times 2 to the x, I'm going to plug in just simply 0, 1, and 2 to find the shape of the graph. So plugging in 0, I'll get 3 times 2 to the 0. 2 to the 0 is 1. 3 times 1 is 3. Plugging in 1, 3 times 2 to the 1 is 6. Plug in 2, we would get 12. So plotting these points, we're at 0, 3, 1, 6, and 2, 12, which is up here. So connecting these with a curve that will approach the x-axis but never get there, approach our asymptote, we have our graph. So the trick to doing these problems of graphing these is to simply graph 0, 1, and 2 into our function. So plugging in 0, well, 3 to the 0 is 1. 1 times negative 2. Okay? Next one would be plug in 1. 3 to the 1 is 3. 3 times negative 2 is negative 6. And plug in 2, and we would get negative 2 times 3 to the 2, which is negative 18. So we're at 0, negative 2, 1, negative 6, and 2, negative 18, which is off of our graph. But even still, with just these few points, imagine a point that's way down here. We can connect these to approach the x-axis here. Making a table of values in order to graph this function. 0, 1, and 2. If we plug 0 in, we'll get 4 to the 0, which is 1. 1 times 1/2 is 1/2. Plug in 1, 4 to the 1 is 4. Half of 4 is 2. Keep in mind you can plug this directly into the calculator. 1/2 times 4 to the 2 on the calculator. And if you do that, you'll get 8. Okay, so we have our table of values, and that means we can go ahead and graph this. We're at 0, 1/2, so 0 just barely up a half, 1, 2, coordinates 1, 2, and coordinates 2, 8, which is right there. So with those 3 points, we can see a curve coming right there. And we can sketch the curve to approach the x-axis the other way, but never get there. In this last problem, okay, so same concept, make a table. 0, 1, and 2, filling in the values for x. But here we have a fraction. But that's okay, because we could still just plug these things directly into the calculator. 4 times ABC for fraction 1/2 raised to the 0. So when you get that, you should get 4. Plugging in 1, we could do these on the calculator. We would get 1/2 to the 1 is 1/2. 1/2 times 4 is 2. Plug in 2, we would get 1/2 to the 2, which is 1/4. 1/4 times 4 is 1. And we see a pattern happening, 4, 2, 1. So we're dividing these by a half, and that's that 1/2 right there. So plotting these points, we're at 0, 4, 1, 2, and 2, 1. So this strange problem with a fraction, we see a bend like right here. So that bend is going to continue to bend closer to the x-axis this way and actually come up this way. So we actually have a graph that's reversed over the x-axis, because our prior graphs were looking like that. But this graph is reversed. I'll see you in class tomorrow. Make sure to do the Schoology assignment.